What is up, guys? Make sure that if you like this video, hit that like button, subscribe, and turn on notifications. What is up, guys? Fahir here from AwesomeTuts.com. Whoa, haven't said that in a while. Anyways, before we start creating anything, I am going to preview the game that we're gonna create. So I'm gonna hit the play button, and you will see now that we have our warriors that they will fight each other. Don't mind the buttocks that you can see from the character. So you see the enemy is chasing us and trying to attack us. Actually, he hit me. Pay attention to the health bars at the top left and top right corner. And by the way, I can hold the shield like this. When I hold the shield, he is not able to attack. And now when I lower the shield, he will be able to attack. You can hear the public behind in the background. Let me just up the volume a little bit. So you can hear them cheering. They like when blood is spit. Anyways, I'm going to attack the enemy. And as you can see, I am dealing more damage because, hey, I don't want to lose in the game that I'm creating. I don't want to embarrass myself. And when his health gets to 0, basically I have to hit him 2 more times. So 1 more time, bam. You see now, he is dead. And voila, I have won. And the enemy's health is 0, as you can see at the top right corner. Basically, this is the game that we're gonna create. We have melee battle system, something we did not do before. We have enemy AI that enemy can detect where the player is and it will chase the player. Also, when the player goes away a little from the enemy starts chasing the player again. So let's start creating this. I'm in a new project. Let me close this one because I don't want it to be open. Let me close it like this. So right click here and finally it's closed. Anyways, this is our project. Here we have our sample scene. This is a new 3D project, by the way. So you're simply gonna go and create a new 3D project. Name it however you wanna name it. I named this one Warrior Fight Game. This sample scene, I am going to change to gameplay just so I like to name things correctly. And we are going to import the assets. By the way, the assets and the complete project are available for you to download. Link is in the description below. So select all of these assets, model, sounds, textures, and UI, and simply drag and drop them right here inside of Unity. Of course, it will take a moment or two for Unity to load all of this. You know the procedure, it takes some time to import the 3D assets. And yeah, while we wait, I can sing to you or we can stop the video. Let's actually try the singing. No. I'm just kidding. I'm gonna stop the video and come back when everything is finished. Finally, Unity took mercy upon us and it has imported all the assets and we can start building our game. The first thing that I want to do is create the terrain or the ground where we are going to stand. And for that, I'm simply going to right click here in the hierarchy panel and go under 3D object and create a simple cube. Voila, this is our terrain. Now, of course, not this cube. We are not going to stand on a cube. Actually, we are, but I'm going to resize it. And I'm going to call it ground. For the scale X, I'm going to say 100. For scale Y, 0.1, because I want to make it, thin like this. I don't want to make it, large. I don't know what's opposite of thin. Don't judge me. Anyways, I'm going to say here Z100 as well. Voila, this is what we have. This is going to be our terrain. Now, of course, it is not pretty at all. I don't want this whiteness tearing my eyes apart. So if you pay attention here inside of the folders or the assets that we have imported, we have textures. Inside of textures, we only have this grass texture. If I open it, this is the grass texture. Basically, somebody took a shot in his backyard. Anyways, what we are gonna do here is we are inside of the textures. I'm going to right click and create a new material. So here it is, right click and create. So again, it's right click and go under create and material. This is what we want. And I'm going to call this one ground material. And we are going to apply it on the ground. So now I can drag and drop this on the ground. And this is how you make game objects look cool, basically. Because pay attention to our ground, it's white. If I put this material on it, it's still white though. But what I can do, for example, is I can change the color to now red or dark or silver or whatever. But I can also drag and drop this grass inside of this albedo or albedo. Do I have my highlight tool? Here it is. So if I take here, as you can see, I have the grass, and if I drag and drop it right here, it will display that grass voila, on our ground. Voila, this is how you make things look good in Unity and in 3D. But there is more to these materials and shaders. Now, this is the first time I mentioned shaders. So what are shaders? Basically, a shader determines how that material or the texture that is applied to that material looks like. So if I take here, pay attention, I have the standard shader. This is on the drop-down list right here. So here it is. I'm highlighting that with my highlight tool. So when you click on that, it's a drop-down list, and you can play with all the different shaders you have built in. Of course, there are others that you can import from the asset store, but these are built in. What I like to use is this one, unlit texture, and you see it's already a little bit different. It's a little bit darker, so the grass looks a little bit darker in comparison to what it looked like a moment ago. And I encourage you to experiment with these shaders so that you can see their effects. Not every shader will make your material look good. Maybe some will look bad, others will look better, but you can find that out if you experiment. So for example, if I go here, I don't know, nature and say speed tree, maybe this will not make it look good. Well, basically it's a little lighter. And some shaders also have other fields here where you can add a texture, you can have a normal texture. Now, I'm not going to go into that, that's a different topic, and I don't know too much about it, but basically when you combine these textures like a normal map, another texture, some other textures that come along with it, you make your material look, or the game object that has that material look good. Anyways, what you need to do is simply experiment with these. Just experiment, try them out, and see different effects that you will get. And that's how you learn the best. Now moving forward, we have our ground, and again, the scale X is 100 and Z is 100, Y is 0.1. Why? Well, because, pay attention, if I set the Y, for example, at 100, I don't want this. What the hell is this? You see, we don't want this. We only want our ground, so we want to make it look like a ground. That's why I put the scale so that it's not too large on the Y-axis. So moving forward, if I go back in assets and models, we have the arena here inside of the models folder. So in the models folder, we have the arena. If I click here, this is our arena. If I drag and drop it, here it is. This is the arena. Dun, 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 dun. Now, of course, it's too small, so we need to resize it. Make sure it is positioned at 0, 0, 0 for X, Y, and Z, and I am going to call it Battle Arena. So this is the name of the game object. And the scale for X, Y, and Z is going to be 25. So 25, 25, 25. And voila, this is our arena. It already has materials applied on it. If you click on the drop-down list, you will see all of these different game objects that are put together to make this arena. If I, deactivate some of them, so if I, let's try deactivate these, you see the effect. If I deactivate them, well, they are gone. So that is another thing that you can experiment. But basically, these are just 3D models put together. So put together to create this battle arena. You can see here we have some people spectating or whatever. Yeah, this weirdo, look at that weirdo. Yeah, these two, they're probably up to something. Yeah, anyways, I don't know what I'm saying, but this is our battle arena. Now, moving forward, we are going to import our character, and here he is, our warrior. Now, one thing to note is this is a headless warrior, so if I drag and drop him here, and if I go to him, voila, this is a headless warrior, like a headless swordsman. But of course, we are going to make him with head. So I don't know how you say head. What's opposite of headless? Head-oness? I don't know. Anyways, this is our game object. So what I'm going to do is, first of all, I'm going to take and rename it. So from body _0, I'm going to rename it to warrior. Next, we need to apply this head on him. So if you pay attention to the head, now it's too big. We're not gonna do this to him anyway. Pay attention to the head. Look at that. We're not gonna do this to him. We are going to resize the head a little. So I'm going to resize it. Let's say here, head is going 1, 1, 1. Actually, no. So the head is gonna be 1.5, 1.5, and 1.5. Yeah, exactly. So 1.5 for the head. This is totally fine. And we need to select the warrior. Click on this drop-down list to go through all of the elements that make him, or to his body parts. So click on the warrior, then this BIP001, click on that drop down list. Then again, you have BIP001 pelvis, click on that one. And let me just resize this here. Then we are gonna go under spine, then spine 1, then spine 2. Man, this model is killing me. Then we have the neck, and right here we have the head. So what you can also do is in the search bar, if I take the highlight tool, here you have the search bar in the hierarchy panel. You can also select the search bar and you can type here, for example, head, and it will find it for you. It's this one right here, BIP001 head. So this is the part of the body that we need. So now we're gonna drag and drop the head right here. Normally we don't have to do this because other models come with the head, but this model is like this. So what I'm gonna do is I am going to resize it, or actually reposition it. So I'm going to say 0.016. This is going to be for the X. For the Y, it's gonna be 0.012. And for the Z, it's gonna be negative 0. Let's say here, I don't know, it's gonna leave it just at 0. Just a 0. Leave the Z at 0. And I think his head is also still too big. So yeah, this is okay. And let's take here and resize the head a little bit. So the scale is going to be 0.47 for X, Y, and Z. I think now it's okay. So when you select the head, set the scale to 0.47. That is 0.47 for X, Y, and Z. The position X is going to be negative 0.0274, and Y is going to be 0.012. And yeah, this is where our head is going to be. Exactly. And it looks good. It looks good. Actually, it looks like it's already built on him. Anyways, as I said, we are not going to do this that often because most models come with the head, but this one is like this. And what we can do, or yeah. Anyways, select the warrior now. And what I'm going to do is I'm going to click on this add component here. And we are going to filter for character controller. This is a built-in controller that comes with Unity. So if I select it here, again, it's under add component and filter here, character controller. As I said, this is a built-in controller, and I don't know if you can see the green things around him. So yeah, I've turned off the ground and the battle arena so we can see this capsule thing around him. Basically, this character controller comes with a collider and also comes with a rigid body in it, so we don't have to apply these things. This green thing that you can see is a collider that's around our player. So what we can do is we can reposition it. So I'm going to put it on Y.96, and for the X I'm going to leave it, Z I'm going to leave it. A radius, however, is going to be 0.25. And voila, you see the radius, it will resize that collider. Now it can be a little lower, I don't know, for example, 0.21, yeah. And you can see now, it is around our player, well, around the middle of him. And this is, as I said, the character controller that we are going to use in order to make him move. And by the way, let me just put him like this. So if I put him like this, and if I hit the play button, actually, where's my camera? He is standing still. Now, even though we have a rigid body, we have a velocity in our character controller, we still need to apply gravity on him. So we need to apply gravity, and in order to apply gravity, basically we do that via script. So it's time to get our hands dirty. Let's go back in the assets and right click here and create a new folder, which I'm going to call scripts. Inside of the scripts folder, we are going to right click and create our player move script. And by the way, before we continue, what I'm gonna do is go back here in assets and right click and create a folder. This one is going to be our prefabs. And click here in the prefabs and drag and drop the warrior. So bam, this is our warrior prefab now. So we don't have to worry about deleting this game object from the scene and doing all of this from beginning. So if we go back in the scripts, we have the player move script, drag and drop it on the warrior, and now hit apply here so that that change applies to the prefab. Now, one thing I want to get out right now. I like when I go and spontaneously have things that I need to explain. Why we need to hit apply to make that change apply to the prefab. And if you're watching my tutorials, you probably heard me saying that like 1,000 times. Well, this prefab right here is basically now the original game object of this warrior that we have in the hierarchy. So let me just take it. So this warrior here in the prefabs folder is the original one. This one right here is a copy of it. Any change we apply to this copy, for example, if I go here and if I attach an audio source component, pay attention here, I have attached an audio source component on the copy in the hierarchy. The original one, the warrior here in the prefabs folder, he does not have that audio source applied on him because we attached that one on the copy. If you want to have the original have this audio source because you attached it, you will need to click on this apply, and this apply applies that to the original prefab, which is right here. Here it is, the original prefab in the prefabs folder. So if I select the warrior prefab in the prefabs folder, it has the audio source component attached on him now. But pay attention now, if I go here to warrior and remove, and this is the warrior in the hierarchy, the copy. If I now remove the audio source component, the original still has the source component, the audio, because we did not hit apply. But pay attention to the difference now. If, however, I select the warrior inside of the prefabs folder, the original one, and if I go here, for example, and filter for a rigid body component, and if I apply that rigid body component on the original, what do you think for the copy? It will have the rigid body applied. Because we applied it on the original, and the copy will simply follow because it's a copy of the original. But if we apply to the copy, then we need to click apply to make that change apply to the prefab, the original one as well. So if I remove now from the warrior prefab the original one, we also don't have it on the copy prefab. So I hope this clears things out. If not, ask what is not clear in the comments below. So let me go here. Actually, this is from the previous one, the one that I have previewed it. So moving forward, this is the new one that we are going to code from scratch. Let me just click here and hold enter to give a little bit space. So what do we need for our player move? First of all, we need our private character controller, and I'm going to call it char controller like this, not character, but char like this, short for character. We will also need an animator, but we will do that later on. We also need here public float movement speed, which is by default 3, and pay attention, I set it to be public, which means it is editable in the inspector panel. And what do I mean by this? When I say it is editable in the inspector panel, that means a public variable is visible here in the inspector. Pay attention here now. You see, we have it right here. Let me click on the highlight tool, and here it is. So we have it. It's right here, which means we can manipulate this value. If I set here value 5, now we have the value 5 and not 3. So if I put it back at 3, it is 3. Basically, the value that we put here in the inspector panel will override the value that is here. So we have the movement speed. We also have a public float gravity. This is what I was talking about, which is 9.8. This is the gravity in real life as well. We also have a public float rotation. So rotation speed, which is going to be equal to 0.15 F. We also have a public float rotate degrees per second, which is going to be equal to 180 degrees per second. So these are the variables that we need to get started. And the first thing that I'm going to do is inside of the awake function, of course we have the start, but I'm going to change it to awake. If you are also following my tutorials, you know that I like to initialize things in the awake function because the order of execution goes like this. When we run our game, this is the first function that is called. The second function that is called is on enable, this one right here. And this is the second function. And the third function is start. So start is the third function, but by default, when we create a project, we have start and update. Of course, we can use start for initialization. And in some cases, it is better to use start over awake. For example, and I know somebody will ask, when is that case? Well, if you are initializing something in the awake function and you need to get a reference for that, then initialize it in the awake, but get a reference in the start function. This goes, for example, if you select a player in the main menu, you initialize the player in the gameplay scene in awake, but you need to follow it with the camera. Then in the camera, use the code that will find the player in the start function. We will have examples for this in some other tutorials, so don't worry about that. Anyways, I'm going to say here chart controller is equal to get component character controller. And voila, we are basically done with our character controller. What is the next thing to do is go here and create void move. And this is a function that we're going to use to move, which we're going to call in the update. And here we're going to have move. So what are we going to do here? First of all, we are going to test if input get axis, and here we are going to say vertical like this, is greater than 0, which means if we have either pressed the up arrow key or the W key on our keyboard, because if I take here quickly the highlight tool, and this is the coordinate system. So here we have Y, here we have X, and here we have Z, because this is a 3D game. And basically up on the Y is plus, down is minus. On the X-axis to the right is plus, which means the positive side, and on the left is negative. And for the Z, forward is the positive and backwards is the negative. And basically here, we are testing if we are touching the vertical axis, which is the Y-axis. That's the vertical axis. But we're going to use this to move our character forward. And right here below, we're going to say else if input.get axis, and here we're going to say vertical. If that is less than 0, then that means we are going downwards. And to paint a clear picture, I'm going to use here print, and I'm going to say the value is, and I'm going to say here plus, and we're going to use this input and vertical so that you can see the output actually of this, what this value will be. So if I go back here in Unity and let me go into the console and clear it. So if I hit the play button, pay attention now, as long as I'm not pressing anything, it will be 0. But when I start pressing, so I started pressing, actually I did not. So now I'm gonna start pressing, and I'm pressing the up arrow key. And this is what we have. Let me just go here because it happens so fast. It's in the update function. It updates every frame in a second. So pay attention here. This is where I started to press, and notice the values 0.04, then 0.096, then 0.14, then 21, then 31, up to 1. So it goes from 0 up to 1 in these increments that we just saw. So 0.1, then 0.15, then 0.2, so on and so forth. You get my point. And for the negative, if you press down, that is the S key or the down arrow key, you will get from 0 to -1. And you saw the increments. It goes slowly from 0 up to 1. If you want to go directly from 0 to 1, then you will use get axis raw. Get axis raw has the same exact effect. It will detect when you click, or actually when you press the up arrow key or the W key, or when you press the S key or the down arrow key. But when you press the up key and W, it will return from 0 to 1, but it will go directly from 0 to 1. It will not go in these increments that we just saw. You can print this and see for yourself. Now, one other thing that I don't like about this code is this right here. Not the word vertical, but instead me hard coding values. This is something I don't like to do. So if we go here in Unity and go back in the project tab, inside of the scripts folder, I'm going to right click and create a new script that I'm going to call tags. So tags, and here I'm going to double click it. We're not going to attach it on any game object. And I am going to remove this public class declaration. So what are we going to do? Why did this go right here? So what are we going to do within our class? Well, first of all, I'm going to create here a public class called axes. And here we're going to have a public constant string. and I'm going to call this one vertical. So vertical axis, which is going to be equal to vertical like this. And we're also going to have a public constant string, and this one is going to be horizontal. So horizontal axis, which is going to be equal to horizontal, as you can assume, because we're going to have vertical and horizontal. Now, don't mind these red errors that I have. This is because my computer was open for such many time or for so long, so I have to close Visual Studio and reopen it again to make this actually work. So now when it's open, bam, here it is. So now everything is working like a charm. As I said, I don't like hard coding values like here, because if we use this on 2 places or even more, it can happen that I misspell something, because if I type vertical with lowercase v, it's not gonna work, even though the word is the same. So capitalization needs to be the same. And when we use it like this, when we declare it in a single place, we can simply do this. Instead of typing it like this, we simply say here, axis dot vertical axis, and bam, this is it. And here we do the same thing, axis dot vertical axis, and bam, it's the same exact thing, except here we have it in one place. And notice here this constant will not change, same like in math. Now you don't have to be a math genius to know that, but basically if I do something like this, if I say axis dot vertical axis is equal to me changing it, it is not going to work because it's a constant. Anyways, moving forward, now we're detecting if we touch or if we press the up arrow key or the W key, and here if we press the down arrow key and the S key. So if we press the up arrow key, we want to move forward, and in order to do that, we're going to say here vector3 move direction is going to be equal to transform forward. What the hell is this transform forward? Well, if I hover over, it says the blue axis of the transform in the world space. In order to paint a clear picture, if I take my warrior here inside of the scene and I zoom him on him, do you see this blue axis, this blue arrow that I'm taking and dragging him? This is that axis, indicating the forward. So no matter where he is, because we can rotate him, if I do something like this and I rotate him, you see now forward is this way, not the way where it was. So basically it was this way forward, but when we rotate him, you saw what I mean. And this right here, the transform forward, is telling us the move direction is to move forward. So now we're simply going to say move direction dot y minus equals gravity multiplied with time dot delta time. In order to apply gravity, this is what I was talking about in the beginning. So when we attached actually the character controller, I said that we need to manually apply gravity to our character, and this is how we do it. This is how we apply gravity, by subtracting from y gravity multiplied with time dot delta time. Why time dot delta time? Well, because we are calling the move function in the update, and if you want to smooth out things, because update is called every frame, or actually once per frame. If we have 60 frames in a second, that's 60 times in a single second this function will be called, which means this one will be called as well because we are calling it in the update. Now, if we subtract from y gravity only, which is 9.8, that's a it's gonna happen very fast. It's a huge number, and we are subtracting that every frame 60 times in a second. That's why we need to multiply it with time dot delta time, and time dot delta time is the difference between each frame. So how many time it took to go from last frame to the next one, that is the delta time. And it's a very low value, and that is the reason why we use it to smooth things out. So moving forward, we have here applying our gravity. The next thing to do is simply call our character controller and move in order to move our game object. So we pass here the move direction. This is where we want to move, multiplied with the movement speed, multiplied with the time dot delta time to smooth things out. Again, smoothing things out with time dot delta time, same reason as what I explained right here. And this is, we're moving in this direction, but we are multiplying that with the speed movement in order to speed up the movement. Now, what I'm going to do is here for our negative, or actually when it's lower than 0, that means we need to go backwards. So I'm simply going to copy these lines of code and paste them right here. And since we don't have transform backwards, we have forward, but we don't have backward, I'm simply going to use the negative. So I'm going to say minus transform forward, which is simply the negative of forward. What is negative of forward? It's backwards. Think of it as opposites. So this is going to have the same effect except backwards. And here we are using move direction, which is now backwards, multiplying that with the movement speed, multiply that with the time.delta time, and we can test it out. So if I go here, and one thing, another tip from me, take notes when I say these tips. If you want, for example, if this is where you want your camera to look, for example, in your scene or when you run the game, instead of using the camera and positioning it, I don't know, at 10, 20, 30 position, for example, and this is where that position is, or dragging it and dropping it, simply what you're gonna do is position here the view how you want it or where you want the camera to look in the scene. Select the main camera in the hierarchy, and on Mac, hold Shift and Command. On Windows, it's Control Command and press F. So when you press F, so now pay attention where the camera is. Exactly same place where we are looking in our scene. Now that we have that done, I can hit the play button and I can test this out. So we have the player and voila, I'm pressing the W key. Now I'm pressing the arrow key, up arrow key, and W, he's moving forward. I'm pressing the back arrow key and now I'm pressing the S key. He is moving backwards. So voila, this works. The next thing on our agenda is to rotate our game object or the player. So let me just go here, and this one is for the move, and here void rotate, and this one is for the rotate, which we are going to call right here in the move. So we're going to say a rotate like this because move is called in the update, and we can safely call rotate below it, or you can simply take the rotate outside and you can call it here. It does not matter, it's the exact same effect. So in the rotate, we are going to say here vector3, which is the rotation underscore direction. By default, I'm going to say it's equal to vector30. This is the default one because vector30 is a shorthand for writing vector3 0 0 0 for x, y, and z. Because we're going to detect input again. We are going to say if input.getAxis, and we're going to say here axis, horizontal axis, if that value is greater, or actually if it's lower than 0. And here we're going to say else if input.getAxis, and again here axis.horizontal. Now here we're going to test if it's greater than 0. And we're going to do the following. So if it's lower than 0, that means we are pressing the A key. Again, this is the coordinate system. This is the horizontal axis, meaning the x-axis. Going to the right side is the positive. Going to the left side is the negative. So if we press the A key or the left arrow key, we're going to the left side, which is negative, which means this right here will be lower than 0. If that is the case, we're simply going to say here rotation direction is going to be equal to transform point, or actually transform direction, and here we're going to say vector3.left. Now I'm simply going to copy this and paste it here, and you can assume that here it's going to be vector3.right. And by the way, this one is going to be separate, so we're not going to do if else or else if. And why did it give me this axis here? Anyway, here I'm going to say if input get axis. We are not going to use if else. Simply we're going to do if and if, because we can press these buttons simultaneously. So if we press the A key or the D key, they will cancel each other out. Anyways, moving forward, what is this transform direction? Well, if I hover over it, it's going to say transforms the direction from local space to world space. What is that? What is local space? What is world space? Let's go back in Unity to explain the local space. If I take the warrior, and of course, I'm going to go in the scene first and zoom in on the warrior. This is my warrior game object. If I right click on him and create an empty game object that I am going to tag here with this orange or yellow tag, you see this game object right now inside of our, so he's basically inside of our game object, our hero. If I move him here, and now he is in front of him. If I take the X, set it at 0, take the Y, set it at 0, take the Z, set it at 0. Now he is back at the center, and his center is around his warrior player. That is his local axis. That is the local axis, his own origin. So his own origin of that game object, and with origin, I mean where that game object goes when we set 0, 0, 0 for X, Y, and Z, or when we reset the position on the transform. Where does he go? That is his origin or his local axis. Local position, that is. If I go here, you see transform direction from local space to world space. But what is the world space? Well, world space is all of this here. You see? Everything that we see here, so where our cube is, or actually our ground, where our battle arena is, where our player is, that is Unity's world space. And this is where we are moving. When we move this character, we are moving him in the Unity's world space. That's where everything happens. So we are transforming the direction here, which is vector 3 left. And if you go here, a shorthand for writing -1 for X, 0, 0 for Y and Z. And the right is +1 for X, 0 for Y and Z. Basically, we are transforming this into the world space, and this will transform it into the left side of our game object inside of world space. And it will do the same thing here for the right direction. So now that we have the input for the left and the right direction, we have here the rotation direction. Right here, we are going to say if input dot, or actually now we need to rotate our game object. So we are going to say if rotation direction is not equal to vector3.0. So if it's not equal to 0, that means that we have here input. And that's the reason why I'm setting it here to be equal to 0, because we are resetting it every time. If we don't reset it here, then the value that we get here will stay the same. And here it will stay the same every single time. So we need to basically reset it here to 0. So vector3, 0. But if it's not equal to vector3, 0, that means we got input here. So what we're going to do is simply we're going to say transform a rotation is equal to quaternion dot rotate towards. And this will rotate from rotation, that is from the transform rotation, to rotation. It's going to be quaternion look rotation, and it's going to be a rotation direction in the given speed, and or actually degrees, and the degrees is going to be a rotate degrees per second multiplied with time dot delta time. What the hell is going on here, teacher? What are you doing? You are driving me crazy. And okay, let me just calm down. I'm gonna not drive you crazy anymore. Anyways, you see here transform rotation is gonna be equal to this. Rotate towards, you see here rotates a rotation from towards to. This is from, so it will rotate from this rotation to this rotation in basically these or this degrees. But this is clear. It will rotate from the current rotation it has towards this rotation right here. Now look rotation basically creates a rotation with a specified forward and upward direction. Basically, this will do the following. Since we are rotating around the y-axis, this is the y-axis, and it will create a rotation around the y-axis, and the forward will be placed on the y-axis. Basically, if the y rotates over here, so now y is here, then the forward will be here. You get my point. Now the reason for that is because, let me take our warrior. You see here, pay attention to the blue axis, so this one right here. If I rotate him, you see how the blue axis rotates along with him? Basically, this is what we are doing with look rotation. It will look at the rotation from the y-axis. It will basically rotate it from the y-axis, which is what we want. We want to rotate on the y-axis. And this is the degrees by which we are rotating the game object. So rotation degrees per second that we added here, 180. Multiply that with the delta time to smooth it out. If we don't smooth it out, every frame we will rotate exactly 180 degrees, and that will be fast, really fast. So if you want to test it out, you can do it by simply doing this right here. Basically, let me just do it, just to test out and show you the effects of the smooth time. So if I go here and if I run the game, so pay attention now if I rotate. You see, this is what happens when you rotate like this. You see, this is what happens because we are rotating so fast. This is 180 degrees per second. If we don't multiply it with the delta time to smooth it out, then you saw the effect. Exact same thing will happen for this here if you don't multiply with delta time. Exact same thing will happen here if you don't multiply that with time dot delta time. But if I hit the play button now that we are multiplying that with delta time, pay attention now, I'm gonna press right actually. So right, you see how he's rotating now smoothly. And left, and he's rotating also smoothly. So now we can move and rotate. So now our game object can move and rotate at the same time. You see? Moving and rotating, and voila. So I'm pressing left and I'm pressing right, and he is rotating towards the direction where I am pressing. Voila, this is how we move a character and how we rotate a character. So the next thing to do is to make the camera follow the player. Of course, we also need to animate him, but using the camera to follow him will be much easier because there is less code involved. So I'm going to right click here and go on create and C# script. And I'm going to call this one camera follow. And I'm going to show you two ways. How can we make the camera follow the player? Because this is programming. There is always more than one way to solve a problem. So select the main camera and drag and drop the camera follow script on the main camera. So drag and drop the camera follow script on the main camera. I'm simply going to double click it and open it here in Visual Studio. And let me just tag the class. And we don't need here that many lines of code. Basically, we need the following. So we need a private transform, which I'm going to call target. And this is going to be our player. We will get to it in a moment. We also need a private vector3 offset. Now, it's a private variable because I don't want it to be accessible in other classes, but I also want it to be visible here in the inspector panel because I want to edit it. So in order to do that, we simply open square bracket and type serialize field, and voila. So open square bracket, close square bracket, in between type serialize field, because now if I go back in Unity, that private variable will be visible here in the inspector panel. Bam, and here it is, right here. And you can simply remove, what did I do? So let's go back here. And you can simply, let me just hide this. So you can simply remove this line of code to test it out, to see for yourself. If you remove it, it will not be visible in the inspector panel anymore. So moving forward, from the awake function, not the start, I'm going to get the target. So I'm going to say target is going to be equal to game object, find the game object with the tag, player tag, dot transform, because we're getting the transform property. Again, two issues we have here. First of all, this right here is a no-no. I don't like it. So we need to go back here in our tags, and we're going to create a public class called tags. And we're simply going to have a public constant string player underscore tag, which is going to be equal to player. This is the first thing and the first issue, same as with our axes, and I explained that why. So if I go back here, remove this, and we're going to say tags.player tag. It's the same exact effect. Now, in order for this to work, you need to make sure that your player, the warrior, when you select him, and right here you have the tag property in the inspector panel, you see where I'm pointing with the mouse, you can click on it. So let me just hide here, and you can click on it, and you need to select the player tag. By default, I think it's from Unity 5 version and upwards, you have here a tag player. If by any chance you don't have it, you're gonna click here on add tag. So click on add tag, and now here where you see tag and list is empty, click on this plus button. So this small plus button right here that I just pointed to. So when you click on it, it will open this short window. You will type here your tag, click save, and then that tag will be available to you. So now that you created a tag, you're simply going to select the game object, go here and tag it. So click on the tag you want to tag it, and pay attention, please, this is a tip, so note it down. If the name here is player with P, capital case P, it needs to be the same exact name right here. If you type here lowercase p, it will not work even though it's the exact same word. So capitalization also needs to be in order. This is really important. So now we have a reference to our player. We have the offset here inside of our, or actually below the update, we're going to create void follow player. And we are going to call this function inside of the late update function. So no update, but late update function. And what the hell is a late update? Well, let me first explain. We have the update function and we have the fixed update function. Update function is called every frame in a second. Basically, if we have 60 frames in a second, then it will be called 60 times. Update function is good for moving a game object using the transform property or the character controller, as we are already doing. And also for getting input, which we are also doing here. So we're getting input. We do that in the update function. Fixed update function is not called every frame, but it's called in a fixed number frame intervals. What does that mean? It's basically called every third or fourth frame. And this right here is dependent, or that is dependent on, if we go under edit and go here under project settings and then time, if you take a look here, let me just clear it with the pencil. You see here this fixed time step is set to 0.02. It's dependent on that time. Basically, fixed update function will be called every 0.02 of a second. And it's good for physics calculations. So if you want to move your game object using the rigid body, you will do it in the fixed update. But what the heck now is the late update? Well, late update is same as update. It will be called every frame, but it will be called after the update finishes. So if we have something like this, for example, I don't know, int a, b, and c, and we want to say here c is equal to a plus b, this calculation will be already done, and we can use the value of c in the late update, and it will be this value here, calculating a plus b, and it will give us the value c, and we will be able to use that in the late update. Late update is really good for using code or typing out code that will be, for example, like this, in order to follow the player, because we are moving the player, as you can see here, in the update. So in the update, we will calculate his position and he will arrive at that position. So now in the late update, we already know where the player's position is and we can follow him smoothly. Now, in order to follow the player smoothly, what we simply need to do is we need to say transform that position, our own position of the camera, is equal to target player, so the target, which is the player transform, as you can see right here, and we're going to use the player transform to transform direction, or actually transform the point, and we're going to transform the point offset. So offset, and basically, let me just go here, I'm going to name it offset position, not to be confused with that wrapper offset, it's offset position. What is transform point? You see here, transforms position from local space to world space. Again, basically, same thing as what we did with transform direction. It will transform this point from the local point of the target. But pay attention here, pay attention please. We're using here target, which is the player's transform, as you can see here. So it's the player's transform. It will transform that point from the position of the player. So from the position of the player, it will transform that point, and it will transform it from his local position to the world position. And if we test it out right now, the beauty here is that our main camera now has these visible in inspector variables for the offset X, Y, and Z. And what we can do when I hit the play button, you will see now where the camera is. It's basically here. But what I can do is I can move here the Y axis, I can move the Z axis, you see now, and I can set it where exactly I want it to be in order to follow our player. And I can set here 0 for our Y axis. And basically what I'm going to do is I'm going to set this at 30. So 30 for the camera for the rotation and 0 for the rotation Y. But if I hit the play button now, you will see that it will transform now the position. And what I can do is this. So voila. You see now, this is how I can make the camera follow the player. Now, of course, here for these values, I'm going to say 2.25 for the Y. And for the Z, negative 1.9. Or actually, it can be a little closer. Something like this, maybe. Negative 1. This depends on you, but now pay attention. Now that we saved, or actually we did not save these values because we are in the play mode. What I'm going to do is click on this gear icon. You see the gear icon on the camera? So click on the gear icon and it will open this list here, and you're going to click on copy component. So when you copy the component now, and if I go back here, you will see that the values are back to 0 because we edited those values inside of the gameplay mode, which means they will not be saved. In order to save it, we did that, gear icon copy values. So now that we have them copied, we're going to see here paste component values, bam, and voila. So now we have the values here, -1 for Z, 2.25 for Y. And if we test this out right now, if I hit the play button, you will think that the camera is going to follow the player, which actually is the case. But if I rotate, you see what is happening. This is not the effect that we want to achieve. Now, we got carried away. We programmed the position of our camera, but we did not take the rotation into consideration. And I like to do things like this. I like to show what is the problem, and I like to show what is the solution to the problem, because we are rotating our character. We saw that. So we are rotating the character right here, as you can see. And let me just move this backwards. So we are rotating the character, but we also need to rotate the camera. So here, I need to say transform.rotation is going to be equal to target.rotation, simple like that. Because our transform rotation is the rotation of the camera. So transform referring to this class or that game object that's holding this class. So transform and rotation is going to be equal to the target rotation, and target.rotation is the player's rotation. So the rotation of the player game object. And now if we go back in Unity and if I hit the play button, you will see that when we rotate our player, we will also rotate, you see, rotating the player, rotating the camera. And we can move the Z-axis, let's say -2. Yeah, -2 for the Z-axis. Remember that, or actually just close the game, select the main camera and set -2 for the Z-axis. So -2. If I hit the play button again, now we move forward, we rotate, the camera rotates along with the player. So this is how we do it. We also set the position and the rotation if we also want to follow the rotation of the game object. Now, is there another way to make the camera follow the player? A more simple way? Of course it is, because this is programming. This is creating an application, and there are multiple ways always to solve a certain problem. This one is much simpler, and for that I'm simply going to duplicate the main camera, and I'm going to set this main camera, turn off the first one, the main one, and this one I'm going to rename to camera in player. So I'm going to rename it to camera in player, and I'm also going to remove the camera follow script because we don't need it. So remove component, so remove the component camera follow script. And what I'm going to do is simply drag and drop this camera on the warrior game object, and it will make it a child of that game object. So basically now wherever we move, if I hit the play button, because the parent is moving, you see now the child is moving as well. And the best thing here is you can position the child wherever you want. So we can say the X position for the camera is going to be 0, the Y position 2.7, and the Z position can be negative, let's say 1.8. So negative 1.8 will be the Z position. And rotation, we can leave 30 for X only. And basically this is how it looks like. So you can rotate it like this, however you want it. But I'm going to set it at 30. Again, you can experiment with this. This is totally up to you. The more you try, the more you will learn. I encourage you to try all the time, so experiment with it. Now that we have this camera as a child of our player game object, I'm simply going to hit play, and wherever the player goes and however he rotates, the camera simply follows without a script, because what the parent game object does, the child will follow. And the warrior here is the parent, the topmost parent. All game objects, when you click on the drop-down list on the warrior, all these game objects are children of the warrior game object. And if we click here on the drop-down list for this BIP001, these footsteps are children or a child game object of this BIP001. So on and so forth, you get my point, but they all are the child of the topmost parent, which is the warrior. Now we need to hit apply because we attach this camera in the player, but again, this is another solution depending on your situation. So sometimes you also want to have the camera inside as a child, and it will follow the player wherever he goes. And it's more simple. Basically, we did two ways. One was using a script, and another one is simply making the camera game object as a child, and it will follow the parent wherever the parent goes. The next thing to do is to create the animations, and we're gonna go here in the models, and here we have the animation. So right here, I am going to right click here where all these animations are. So right click, and I'm going to create an animator controller. So click here, and I'm going to call it warrior controller, like this. Because if I select the game object, which is our warrior, you will see that he already has an animator component attached on him. So here it is. And we simply need to drag and drop this animator controller, the one that we have just created. We need to drag and drop him right here in this empty field. And then we can add animations to it, and we can control it via code. So if I take here the warrior controller, drag and drop it here, bam. So this is the controller now. We have it attached on the animator of the warrior. The next thing to do is go inside of the animator tab itself, and this is where we are going to create the animations. Now, if you don't have this tab, what you're gonna do is the following. Go under window, and then you have here animation, and here it is, animator tab. So this one right here. So you have the animation, you have the animator. We want the animator, so animator, this one right here. Now, in order to create these animations, basically we don't need to. They are already created here, but we only need to connect them with the controller. So while you're in the animator tab right here, right click and create state and empty. So right click, create state, empty. Voila. This is going to be the idle animation. And in order to rename this one, you see the name is new state. If you want to rename it, simply click on it. And now here in the inspector panel, you will see here at the top, let me just go here and clear the console, or actually clear the pencil. So here it is, you see the state, this is where you will rename it. And here where it says motion is where we are going to drag and drop the motions or our animations. So here new state is going to be idle. And simply what we need to do here is, you see we have the idle 0 and we have the idle attack. So if I select this one, this is that animation. If I go here and preview it, so click the animation, basically clicking on the drop down list for this idle. And here we have idle _0. Now, if I preview it, so if I zoom in on this preview here at my bottom right corner, and this is the idle animation. I'm not gonna preview the whole animation because it's long. So go back here in animator, click on idle, and here where I said that you need to drag and drop that animation or motion, right next to it, you have a little circle. Let me show that circle. It's right here, you see? When you click on that circle, you will be able to select these animations. So here we have idle 0 and select the idle 0, and voila, idle 0 is not here. Why? Well, if we go here in the console, it says animation clip idle 0 cannot be used in the state idle. Legacy animation clips are not allowed in animator controller. What does that mean? Basically, it means the way how we import them. So we need to select all of these animations. So select from attack 0 to idle attack 0 and walk. Select all of these animations. And right here now, inside of the inspector panel on my right side, you see here we have model tab, we have the rig animation, material model, so on and so forth. Click on the rig tab. In the rig tab, we're going to change the animation type from legacy to generic. So again, click here, generic, click on the drop down list where it says legacy, which is right here, this right here, you see? When you click on that drop down list, you will change it from legacy to generic and you will hit apply and bam. Unity will, you see, like re-import these assets with this animation type, but it will re-import these assets right here, only these animations. And of course, it takes a little bit of time where I can use it to sing na 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 na. No, I'm just kidding. Anyways. I have fun recording these videos, man. Anyways, animation type will be generic and you hit apply and you see Unity re-imports them and voila, we are good to go. So now select the idle animation, click on the circle and now select the idle _0 animation. It works. Here is our idle animation. I can even now preview it if I select the warrior inside of the hierarchy panel and if I go into the animation tab. So not the animator tab, but animation, which is located here. Window, animation, and animation. This is the animation tab. So I can click here the play button to preview it, and now we are previewing basically previewing the idle animation for our player. See, he's like moving. This is all the idle animation. Everything here that you see is basically the idle animation. And why am I actually running the game? Anyways, this is the idle animation as you just saw. So let's go back and create the rest of these animations. So we have here the idle. We are also going to have the walk animation. So right click here, create an empty state, and I'm going to call this one walk. And I'm going to click on the little circle, and I am going to select the walk animation. We are also going to have the attack animation. So right click here, empty state, and this one is going to be attack 1, and like this. We are also going to have another one for the attack, but let me just click here on the circle, and for the attack 1 I'm going to select attack _0, and let me just preview it quickly. So attack _0, yeah, this is the one I want. And right click again and create an empty, and this one is going to be attack 2, rename it to attack 2, and for the state I'm going to select attack _1. But let me quickly preview it here. So attack _1, if I preview it, yeah, exactly, these two. So underscore or attack _0 and attack _1. And the last one is going to be create empty. And this one is going to be our defend animation. So defend like this. And for our defend animation, I'm going to click on the circle, and here we have counterattack damage defense _0. So select the defense _0. Again, if we preview it, it will be this one. You see, he's like moving his arm upwards to defend from the attack. So now we have these animations. We need to now create a script and handle these animations via script. So when we move, we want to simulate or play that move animation. When we attack, we want to play the attack animation. You get my point. But how can we do that? Well, in order to do that, we first need to create something that is called a parameter. So we need to create something that is called a parameter, and here click on the plus sign. So click on the plus sign, and the first parameter that we're going to create is going to be the walk parameter. And if you notice, I clicked on the plus sign and selected the bool. So I'm going to do it again. So delete it, click on the plus sign, and this one is going to be a boolean. We are going to call him walk. So a boolean walk parameter. Now, the next parameter, we're going to click on the plus sign here, and we're going to create a trigger, and this one is going to be defend. And we're going to click on the plus button here and create another trigger. This one is going to be attack 1. Click on the plus button, trigger, and again, attack, but now 2. So attack 1 and 2. Walk, defend, attack 1, and attack 2. These are parameters because we need to have transitions. What are transitions? If I right click on the idle animation and I click here make transition, I can now point on the walk animation and click on it. Bam, you see this white line going from idle to walk? That means this is a transition from idle to walk animation. That means when we call this transition in our code, we will go from idle to walk animation. But this transition, in order for it to happen, it needs to have a condition, and this condition is right here. When you click on this line here, this arrow, when you click on it, it goes blue, and you have the properties here in the inspector panel. When you scroll a little bit down, you will see here conditions, and it's a list where we can click on this plus sign to add a condition. Well, the conditions are gonna be these right here, these parameters. So for example, if I click on the plus sign here and I'm gonna go from idle to walk, when the walk parameter is equal to true, and notice here in the drop down list I can select true or false, because when we created this parameter it was a boolean. Boolean has a value true or false. So we will go from idle to walk animation when the walk parameter is or has a value true, and we will set that in our code. So we will set it in the code for it to have the true value, and when that happens we will transition from idle to walk animation. Similarly, Right click on the walk animation and make transition to the idle. And now we have two arrows, one pointing from idle to walk and another from walk to idle. So click on that arrow. And now I'm gonna click on the plus button here, and the walk here is gonna be false. Because when walk is true, we are gonna walk. When walk is false, we are gonna go back to the idle animation. Now we are also going to go from our idle to attack. So click on idle, make transition to attack. And we're also gonna make transition from attack back to idle. So click on this transition from idle to attack, and the condition here is going to be attack. Simply this right here, attack 1, because we're gonna go from idle to attack 1. It's a trigger. We will trigger that in our code. We will see if something is not clear right now. Wait until we get to the code part. Then I will have more material to explain it more clearly to you. We will see it visually and it will be even more clear. So we're also going to go from idle to attack 2 and make transition back. So click on the transition from idle to attack 2, and the condition is going to be attack 2. Don't worry about the transition from attack to idle. We will cover that. So don't worry, we will cover that. But basically, from attack 2 to idle, the transition or the parameter is going to be when walk is equal to false. Same here. From attack 1 to idle, the transition is going to be when walk is equal to false. Because why when walk is equal to false? Because we're also going to have from walk to attack 1 and from attack 1 back to walk. And this transition from walk to attack 1 is also going to have a attack 1 trigger parameter. But this parameter here, when we want to go back from attack to walk, that's when the walk will be equal to true. And similarly here, so from attack 2 back to walk, and from walk to attack 2, click on the transition from walk to attack 2, click on the plus button, and here we're going to select attack 2 trigger. And from attack 2 back to the walk will be true. But we will do something else here as well, so don't worry about that. We will come to it. We are also going to go in our code, and then everything will be clear. Now we're also going to go from idle to defend and back from defend to idle. So when we want to go from idle to defend, that's when defend will be equal to true. So when we click here, actually this defend parameter, excuse me, we're going to delete it. It's going to be a Boolean. So click here, bool, and defend is going to be a Boolean parameter, not a trigger. So attacks are going to be triggers, but here we're going to go from idle to defend when the defend parameter is equal to true. And we are going to go back from defend to idle when defend is equal to false, right here. Now we're also going to go from walk to the defend, and here we're going to set the condition defend is going to be equal to true, but we're not going to go back from defend to walk. We're only going to be able to go back from defend to idle animation. Now this is for setting them up. We will see them again in action. We will see them in action. Don't worry about that. Now, before we start coding, because we're going to go here in assets and scripts, and I'm going to right click here and I'm going to create a new C# script, and this one is going to be character animations. This is where we are going to create our animations. So this is where the animation magic is going to happen. But one thing to note is, remember those parameters that we used? Now let me demonstrate that. So here we're going to have a private animator, and I'm going to call him anim. And in the awake function, we are going to get a reference to it. So anim is equal to get component, animator component, voila. Now, this is where we are going to create our animations. And our first animation, I'm going to delete the update function, is going to be public void walk, which takes a bool. So bool walk parameter. And in order to execute it, we need to call here anim set bool. And that bool is going to be our walk parameter. And we're going to set the value to this walk that we pass right here. So we're going to set that walk, because we need to call it with the name. That's why we named it here. If we go here in the animator, and if we go into the parameters, you see the name is walk. It's same as with find game object with tag. So it's same with tagging. We need to have the name here. You see the walk, it's capital W. So also here it needs to be capital W or otherwise it will not work. Now this is what I was talking about a minute ago before we create these. You see we have these parameters, and you know I hate hard coding. So we're gonna go here in tags. Now when I say I hate hard coding, there are some exceptions where you will use hard coding like this instead of creating it here. But we will see examples of that in some other tutorial. Don't worry about that. So don't worry that you will never use hard code. But if you're gonna use it often, it's better to put it here in a single script. So here I'm going to create a public class that I'm going to call animation tags. So, or actually not animations, animation tag without S here. And here we're going to have a public constant string. This one is going to be the walk parameter. And we're going to say here walk. So the value is going to be equal to walk, capital W, so capital W, or otherwise it will not work because the names need to match up. If here you have a lowercase w, so if here you have a lowercase w, then here as well you will use the lowercase. The point is the name you put here for the parameter, it needs to be exactly the same name you put right here. So we also have a public constant string defense or defend parameter, which is going to be equal to defend like this. This is the value, this is the name. And we're also going to have a public constant. So it's not connection. What am I doing here? Const string. And this is going to be attack underscore one underscore trigger, which is going to be equal to attack one like this. And public, so it's public constant string, not public, it's public. And instead of using here attack underscore two underscore trigger, because I want to differentiate them, I think it will be better if we put them like this. So it's attack underscore trigger underscore one and attack underscore trigger underscore two, because I can see this one and two clearly when they are at the end of the name, instead of when they are in the middle of the variable name. So now we have everything basically, and we can go here in our character animations. Here for our walk, instead of using this, we're simply going to call our animation tags dot, and we're going to call the walk parameter. Bam, here it is. We are also going to have a public void defend animation, and here we're also going to have a bool defend, which is a parameter that we're going to pass. And here we're simply going to call animSetBool, and you call the parameter by the name. So let me explain that. So animation tags dot defend parameter, and here I'm going to call defend. And yes, I notice here that I did not type parameter, so I need to go back here in tags, and it's the defend parameter. Thank you very much. You see here, I'm calling setBool because when we created this parameter, we created it as a bool. When I click on the plus button and click bool, it's created as a bool. So you will call setBool. If it's an integer, you will call setInt. If it's a float, setFloat. If it's a trigger, setTrigger, which we will see right now. So here we're also going to have a public void attack underscore one. And here we're simply going to call anim set trigger, not target, but set trigger. And simply here we're going to call animation tags. So animation tags dot attack one trigger. Bam, it's like that. You see set trigger. And for attack two, I'm going to duplicate this and paste it. And here instead of attack one, I'm going to say attack two. And here instead of underscore one, I'm going to say underscore two. And basically that is that. Bam, we are done with our animations. See, this is a class, and this is how I like to do things. I like to create a separate class for everything, and this is how Unity prefers it. Now, this is not my wisdom. I've heard that, I don't know what was the name, Will Goldstein or that Alan guy, the guys who do official Unity tutorials. I was watching one of their tutorials, and yes, I watch tutorials, don't judge me. I mean, I'm saying don't judge me, but you should also watch other tutorials as well. Anyways, I heard him saying that Unity prefers that you have a separate class for every separate task. So I like to separate my tasks. So here, this class will only handle animations. And now when we want to call these animations, for example, the move or the walk, we simply go here in the move script, And right here below our private character controller, we're going to say private character animations, and I'm going to call this one player animations or player animation, however you want to say. And here in the awake, I'm going to say player animations is equal to get component character animations. I'm calling it character animations, the class name, because we are also going to attach this on our enemies. Now, before I animate anything, I'm gonna go here in Unity and we need to attach that script on the warrior. If we don't attach it, it will not work. So select the warrior, click on add component and filter for character animations and click on that script and hit apply so that that change also applies to the prefab. So if we go back now in our Visual Studio, so if I go back here, at the bottom, I'm going to create void animate, and this is going to animate the walk. So animate walk, this is how I'm going to name it. So animate walk. And how are we going to animate the walk? Well, basically I said that the move direction, it is moving, so it has velocity. We can test it out, so we can call here if move, actually I'm saying move direction, but it's actually a character controller, so excuse me for that one. So the character controller, we're using it to move, so we can test it out. So we're going to say here if our character controller dot velocity dot square root magnitude is not equal to 0, then we are going to animate. We are going to call player animations dot walk is equal to true, else here we are going to call player animations dot walk is equal to false. Bam, bam, bam. What is this? Why are you bamming, teacher? I don't know why I'm bamming, but what this here is, we have our character controller and we are going to get the velocity. You see, the velocity is the velocity, speed over time. If we are moving, velocity will increase over time. Only if we are standing still. Now, this is from physics. I'm not no physics guru. I just know this from looking online. It's really very simple. So as I was saying, if we are moving, velocity will increase over time. If we are standing still, velocity will not increase. Think of it like you have a gas pedal in your car, and when you are pushing the gas pedal to the end, you know, the car does not go from 0 to 100 in a second. No, it goes slowly over time. Well, that slowly over time is the velocity. So if the velocity and the square root magnitude, you see this square root magnitude, and I need to do it like this because for some reason Visual Studio is giving me here some errors, I don't know, warnings for whatever reason, but let me go here, character controller, so char controller dot velocity, you see the current relative velocity of the character, meaning if he's moving or not. That the square root magnitude, it returns the length of this vector because the square root magnitude, basically, this velocity is a vector value. A vector has a value of x, y, and z. And why that? Because we have speed on the x, y, and z axis, and it will return that speed. This square root magnitude will make that value 1, which basically means if that value is not equal to 0, we are moving. So if that value, the velocity's square root magnitude, think of the square root magnitude simply converting this value into a 1, so number 1 value. If this velocity has any value, if it's 0, then it will return 0. The square root magnitude will return 0 if we are standing still. If we are moving, we will have any value here. We will convert that value to 1, which will not be equal to 0, meaning we are moving, meaning we will animate the walk. Meaning, if we are not moving, then we will not animate the walk. Instead, we will animate the idle animation. Before we proceed to test this out, we need to call the animate walk in the update function. So animate walk function, call it in the update function. And now we are ready to test things out. So if I go back here in Unity and if I hit the play button, when I move, we will see that we are not animating. Now, what is the reason? Pay attention here to the idle animation, this blue line. When this blue line finishes now, I'm gonna go to walk animation and walk animation freezes. What the hell is going on, teacher? You said that this right here will work, and why is it not working? First of all, let me fix these animations. So if I double click on the idle animation here, we need to make sure that the loop time is checked. So when you select the idle, if you double click on it, it will take you here to the settings of the animation. And if you scroll a little bit down, you have this loop time, which is right here that I have circled right now. This loop time, it needs to be checked because the idle animation needs to loop. And when you check it, hit apply at the bottom left, or excuse me, bottom right corner. Also do the same thing for the walk. Select it, double click it, scroll down, hit the loop time and hit apply, because again, the walk animation needs to loop. It needs to play over and over and over again for us to be able to simulate the walking and the idle animation. The defend animation here, so select it. For the defend animation, we will leave it for later. We will see what we're going to do with it because we're going to add some extra code for that as well. So we will leave it for now. These attack animations are not going to loop. But now, since these animations are looping, if I hit the play button, pay attention here in the animator. You see animations are moving. You see this blue line? It means that the animation is playing. But if I try to move, you see I'm moving, but you see only now the animation is playing. I don't know if you see this, and you pay attention here. You see what is going on? You see here? Now, what is the reason for this? Well, the reason for this are these transitions. So we need to fix them. If you select the transition from idle to walk animation, you will notice here that we have conditions. We set the conditions to be true. That is okay. But you also have these settings here, and you have the exit time. And pay attention here, this exit time, transitions has a fixed exit time. And if I hover over the exit time, it will say exit time in normalized time from current state. Basically, this means this exit time is how much time we have before we exit from the animation. And usually this means that we will let the animation to play till the end, which we saw. The blue line was filling up in the idle animation, and only when the blue line has finished filling up, that's when we transitioned to the walk animation. So in order to fix that, we're going to uncheck the has exit time, and the transition duration we're going to say at 0.1 because we want to transition as fast as we can from our idle to the walk animation. Now, in regards to the walk animation, we're going to do the same thing. So click here, the transition from walk to idle, uncheck has exit time, fixed duration is going to be equal to 0.1, simple like that. So what about transitions from idle to attack? Basically, we can test these two out first. So if I hit the play button now, pay attention. Now I'm going to hit, or now I'm going to start walking. You see, as soon as I started walking, he started to walk. You see, as soon as I started to walk, and here, what we need to do is the transition, or actually the condition is false, but I think in the code. So else, player animations, walk is equal to false. Something weird is going on here because the parameter here is okay, it's false, and we saw that in the animation nothing is wrong. So let me try this. I'm gonna print here and I'm gonna say the velocity is colon, and I'm gonna say plus character controller, or char controller dot velocity dot square root magnitude, and I'm going to print that out to see the value quickly. So if I go here, let me just clear the console. And if I hit the play button, we'll see that initially it's set to 0, but now I'm going to start moving. So now it's 9 points, so on and so forth. I'm stopping, so I stopped moving. Whoa, never saw this before. You see, I don't move, but for some reason the character controller still has velocity. Now I'm really not sure what is going on, but let me try this. Let me try to stop our character controller instantly. So basically here, we're checking if input, so on and so forth. If we have input, we will move our character controller. Else, if we don't have input. So basically here, if we don't have any input to move the character, then we're simply going to say character controller.move, and here we're going to pass vector30. Again, vector30 is a shorthand for writing 0, 0, 0 for X, Y, and Z. And basically, it will stop the character controller from moving. So if I go back here in Unity and clear the console, and if I hit the play button, so if we go now, and if I stop, bam, it stops. You see, we just need to stop it, but I'm not sure why it's not stopping on its own. I'm using the same code from the project that I showed in the beginning. it's the exact same code. I'm following that. It worked like a charm. I did not use this character controller move 0, but basically if you have this issue, this is how you will fix it. And if I get to bottom of this issue, I will create a video talking about what the issue was. It's really interesting to see, but this is how we fixed it. So yeah, you need to improvise in programming as well. So this is how we stopped our character controller to make sure that the square root magnitude is equal to 0 indeed. So what I'm gonna do again is test it out so that we can see in action our transition. So if I walk now, you see automatically he goes from idle to walk. I'm gonna stop, automatically he goes back from walk to idle animation. The reason for that is because we edited these transitions, so we don't have the exit time. Transition duration is 0. Basically, exit time will allow us to finish the animation before we transition to another animation. And transition duration is how much seconds it will take for this transition to happen. So we set it 0.1. We want to happen as fast as possible. And we saw this in action. So now things are clear. You see here, we go from idle to walk when the walk parameter is equal to true. This is what we're doing here. Parameter walk is equal to true. And if I go into character animations, anim set bool, this is the walk parameter. We set it to this walk parameter that we have here. And we specify that walk to be either true or false. So if it's true, it will transition from idle to walk. And if it's false, it will transition back from walk to idle. And we talked about these parameter conditions or settings, exit time, fixed duration, so on and so forth. We explained what they are and what they did. And so now the animation is a little clearer, if not a lot more clear, what we are doing here. Now, this is in regards to the idle and the walk animation. We, of course, have these transitions that we need to fix, but I would rather first test it out and then we will proceed to fix them so that we can see it in action and make the animation concept even more clear. So for that, we need to go here in our project and scripts folder and right click here, and we're going to create a C# script that I'm going to call player attack input. And this is where we're going to get the input for the attack, and we are going to proceed to attack. So of course we need to attach this on our warrior character, and I'm going to hit apply. And now we're going to double click and open this script in Visual Studio. The first thing that I'm going to do is tag the class here at the bottom and give a little bit of space so that I can scroll up and down and we can see more clearly what am I doing here. So for now, the one thing that we need for our player attack input is going to be our character animations, and I set it to be private because we will use get component. And I'm going to name it player animation, and inside of the awake function, so change start to awake, we're going to say player animation is equal to get component, and we're going to get here the character animations component like this. So what is the next thing to do? Well, the next thing to do is to detect input. So we need to detect input in order to simulate the attacks, and we will simulate them with the animation. So when we press our key code, let's say J and K, so when we press J, we will defend ourselves, and when we press K, we will attack. So here, if our input get key, and we're going to say here key code dot J, so when we press J, we are going to defend ourselves. So defend when J pressed. And simply here, we are going to call our player animation. So we're going to say player animation defend, and here we're going to say true, because if you remember, if I go back here in Unity and inside of the animator component, or actually in the animator panel, you see here defend, we will go from idle to defend when defend is equal to true, and we will go from walk to defend when defend is equal to true. Now going back here, we set it to be equal to true, which means that when this is called, we will play the defend animation. Now this is when the key is pressed. What we want to do when the key is released? Well, we want to say here if input dot get key down, and this is going to be key code, so key code dot J. Same key when we press it and when we release it, we are going to say here player animation defend now is equal to false. We will test this out in a moment. We will see some issues and we will fix them one by one, because I like to first show you the problem and then show you how to get to bottom of that problem. And here we're also going to say if input get key, and we're going to say here key code K. So when we press K, we are going to attack. But we have two attacks, if you remember. If I go back here in Unity, you see here we have attack 2 and we have attack 1. This is in our animator panel. So here they are, attack 2 and attack 1. So if I select the warrior here and if I zoom in on him, you will see here that if I select the attack 1 animation, you see now this is how he is attacking. If I select attack 2, this is how he is attacking. So how can we call these animations? Because I want to randomize that. And in order to randomize it, when we press our key code K, we're going to test here if our random.range from 0 to 2, if it's greater than 0. Now to declare this right here, right away, or actually to explain it. You see this random range will return a random value between two numbers. When we use integers, if I hover over here, you see it is using integers. If we say here f and here f, it will think that we are using floats, which you will see here when I hover over random float. As you can see, random range for a float. But if I remove f and set it to be an integer, or actually just remove f, it will think we have integers. Why is this important? Because when it comes to integers, this number here is inclusive and this number here is exclusive. What does that mean? That means that inside of this random range, it will include this number, but it will not include this number, which means basically here it will return either 0 or 1. 2 will not be returned. It will return either 0 or 1. And if we have here, for example, 5, it will return 0, 1, 2, 3, and 4, but it will not return 5. So 5 is excluded. But if they are a float, so if I say here f, so 2f and 0f, that means we can either get 0, 1, or 2, or in between decimal point numbers. So when it comes to a float, both numbers are included. When it comes to an integer, then the second number is not included, which means this will either return 0 or 1, which means 50-50 chance to perform one attack or the second attack. So here I'm going to simply say player animation dot attack 1, and here I'm going to say else, and I'm simply going to say attack animation 2. So player animation and attack 2 animation, and voila, we are good to go. And since this is already being called in the update function, we can safely test it out. So we need to go here in Unity and pay attention now what is going to happen. So here I'm going to hit the play button. Pay attention to these animations. So let's say I press K. You see I pressed K. So what is happening? First of all, we need to wait for our random integer to pass. And let me just go here quickly. So here I'm calling attack 1 and here I'm calling attack 2. And in character animations, so here animations attack trigger 1 and here we have attack trigger 2. So let's go back here again and what is going on. Pay attention what is happening here. So I'm gonna press it and now we have attack 2. But again, we need to wait for the idle animation to finish because we did not check for these transitions. And now he's attacking and you see how much it takes to play the attack animation. So we need to fix this. And of course, in order to fix this, we are going to fix the transitions. So the transition from idle to attack 1, so here, it's not gonna have an exit time. And for the transition duration, I'm going to say here 0.3. This is from idle to attack 1. But when it comes to attack 1 back to idle, it's gonna have an exit time. And here the transition duration, I'm going to say 0.1. So the transition duration will be 0.1, but it will have an exit time with the value of 1. For our transition from idle to attack 2, we are not going to have exit time and 0.3 will be that transition duration. For this transition from attack 2 back to idle, we are going to check the exit time and the value will be 1. And here the transition duration will be equal to 1. Now when it comes from our attack or from walk to the attack animation, so this one right here, to attack 1. Uncheck exit time, 0.3 for the transition duration. Going back here from attack 1 to walk, we are not gonna have, or actually exit time is going to be 1, and transition duration is going to be equal to 6. And similarly here, from walk to attack 2, we're not gonna have an exit time, but 0.3 for the transition duration. And for our other transition, same as with from attack 1 to walk, we will use the same thing for attack 2 to walk. So exit time will be 1 and transition duration will be 0.6. And for our defend, so we are also going to fix defend now because it will have the same issue. It will have the same issue as we just saw. So we are going to say here uncheck exit time and 0.3 for our transition duration. We're going to do the same exact thing here from walk to defend. So uncheck exit time, 0.3 for transition duration, and going back from defend to the idle animation, 1 for the exit time, 0.6 for the transition duration. So now let's test it out and see what we have here. So if I go and test it out again, so pay attention now. Did you see, I don't know if you see here that we are attacking with 2. We attack just 2. What is, you see here? I just pressed the number, I just pressed it once. You see, I pressed the animation only once, as you can see here. So again, but it's attacking multiple times. You see here, now I'm not even pressing a button. Now you're like, okay, teacher, do you know what you're doing? I do know what I'm doing, but I want to show you.